Welcome back to the Deep Dive. Today, we are going to do some decluttering. And honestly, I was excited because when I saw the topic minimalism, I was ready.
Oh, yeah.
I've been looking at my apartment, looking at that pile of books I'm never going to read, thinking about throwing it all out. Maybe buy one of those uncomfortable mid-century modern chairs and just, call it a day.
I hate to break it to you, but you might want to keep the books. And the chair won't help with what we're discussing today.
Yeah, I realized that about page 2 into the reading.
Yeah.
We are not talking about interior design or lifestyle trends. We're talking about something, well, it feels infinitely more complex.
It is.
We're talking about the architecture of the human mind.
We are. Specifically, we're looking at the Minimalist program in linguistics. We're deep diving into a text called Minimalism in Syntax, specifically focusing on Chapter 4.
Right.
And this isn't just about grammar rules. It's not about where to put a comma or, how to diagram a sentence like you did in 8th grade.
Which is a relief, because I was terrible at that.
This is more like evolutionary biology or physics even. The text is asking a question that sounds simple, but is actually kind of mind-bending.
And what's that?
How perfect is language?
See, that's the part I got stuck on immediately. Perfect. Have you heard people speak? Have you heard me speak before my first coffee? It's a mess.
Right.
We stutter, we use filler words, we trail off. I mean, it feels like the opposite of a perfect system.
That's the first distinction we have to make. The text in the Minimalist program in general isn't looking at your performance. It's not looking at the ums and us or the fact that you forgot a word.
Okay.
It's looking at the machine itself, the operating system running in your brain.
So you're saying distinguish the software from the user error.
Exactly. The idea is to strip away all the noise, all the complicated theories linguists have built up over the last 50 years, things like deep structure and surface structure, and just ask, what is the bare minimum required for language to work?
Okay.
Is it a messy biological accident? Or is it an optimal solution to a specific engineering problem?
It's the Marie Kondo method for scientific theory.
How so?
Does this theoretical level spark joy? No. Toss it.
Ideally, yes. The text starts by trying to define what a language actually is in this stripped-down model. And this is where it gets a little technical, so stay with me. It defines a language, let's call it L, as a generative procedure.
A procedure.
Like a recipe, like a computer program.
Yeah.
A procedure that constructs pairs. The text labels these pairs, pi and lambda.
Okay, pause. You can't just drop Greek letters on me without a warning. I haven't used pi since geometry. What are we actually talking about here? Why the math?
Because the Minimalist program views language as a computational system. Think of it this way. The language faculty in your brain is a machine, but a machine is useless if it's just spinning gears in the dark.
Right.
It has to connect to something. It has to have an output.
Okay.
It has to connect to 2 specific systems in your body. First, it has to talk to the articulatory-perceptual system.
That's just fancy speak for my mouth and ears.
Right. The sensory motor system. The physical machinery that makes and hears sound. That's pi, the phonetic form.
Okay.
It's the set of instructions your brain sends to your vocal cords.
Got it. So pi is the audio file.
And secondly, the machine has to talk to the conceptual-intentional system.
Which is my mind.
Your mind. Your thoughts, your meaning, your intent. That's lambda, the logical form.
So in this view, language is basically just a bridge. It's the driver software that connects the hardware of my thought to the hardware of my voice.
That is the core of the interface theory. The text argues that a linguistic expression consists only of these 2 interface levels, pi and lambda.
Just those 2.
Sound and meaning.
Only seems like such a strong word.
Yeah.
What about all the other stuff? I remember hearing about deep structure in college. Where does that go?
In the trash.
Really?
That's the radical part of this text. It argues that there are no intermediate levels, no middle management in the brain's grammar department. There is the beginning, the words you pick from your mental dictionary, and the end, where they hit the interfaces. Anything that isn't legible to those interfaces shouldn't exist.
Okay, so if we fire the middle managers, that puts a lot of pressure on the final product. The text mentions a rule called full interpretation.
Yeah.
Is that like the quality control?
It is. Full interpretation basically says, when the derivation, the process of building the sentence is finished, there cannot be any junk left over.
Junk.
Uninterpretable features. Imagine you're writing code for a website. If you leave a random string of nonsense characters in the middle of the code, what happens when you try to load the page?
It crashes. Or you get that spinning wheel of death.
The text literally uses the word crash. If the language machine builds a sentence that contains elements the performance systems, the mouth or the mind, can't read, the derivation crashes.
So a crash isn't just I made a typo. A crash is system failure.
Right. For example, if you have a sentence where the structural requirements don't match, like a plural noun trying to agree with a singular verb in a way the system prohibits, the computation fails. The instructions are just garbled.
Okay, so the opposite of a crash is what? A success. A win.
A convergence.
Mm-hmm.
A derivation converges if it yields a representation that satisfies full interpretation at both levels.
Both. So it's all or nothing.
It has to work for sound and it has to work for meaning.
So our brains are constantly running these simulations, trying to build sentences that don't crash.
Constantly. But here's where it gets really interesting. It's not enough to just not crash.
There's more.
The text introduces the economy condition.
Oh, I loved this part. This is where the text basically accuses the human brain of being lazy.
Efficient is the preferred term, but yes. The text states that the derivation must be optimal. It says, and I'm quoting here, less economical computations are blocked even if they converge.
That is wild. So even if I could say a sentence in a long, roundabout way, and it would technically make sense, my brain might physically block me from constructing it.
Yes, if there is a cheaper version available.
A shorter path.
Exactly. The system is designed to take the shortest path. It wants to do the least amount of work possible to get the job done.
But wait. I spotted a loophole here, and the text actually brings it up too.
Okay.
If the rule is, do the least amount of work possible, I know the winner.
Oh.
The lazy teenager strategy, do nothing. The most economical derivation is to not speak at all. Zero operations, zero energy, perfect efficiency.
You found the paradox. If no work is always better than some work, we should all be silent.
Right. We just sit here staring at each other. This deep dive would be 18 minutes of dead air.
Which would be very economical, but terrible for our ratings.
Definitely.
The text addresses this by clarifying the rules of the competition. The system doesn't compare speaking versus not speaking.
It's not an option.
It compares speaking this way versus speaking that way.
Okay. It only compares convergent derivations. It looks at the set of all the valid ways to express your thought, the winners that don't crash, and then it picks the most efficient one among them.
So it's like a race. You don't compare the runners to the guy sitting on the couch.
Right.
You compare the runners to each other to see who took the straightest line.
Precisely. We are looking for the optimal path among the survivors.
Okay, so we have this picture of a hyper-efficient, crash-avoiding, sort of perfect biological machine. But, and this is a big but, if the system is so perfect, why does language feel so weird?
Weird how?
Well, the text spends a huge chunk of time on displacement, things moving around. If I'm packing a suitcase efficiently, I put the socks with the socks. I don't put one sock in the main compartment and the other one in the front pocket.
But language does that all the time.
All the time.
It does. Displacement is the imperfection that keeps linguists up at night.
Explain it for anyone who might not remember their grammar classes. What is actually moving?
Think about a simple question. What did you buy? Okay. What did you buy?
Now, think about the meaning of that sentence, the lambda side. You are asking about an object that you purchased. Logically, the word what serves as the object of the verb buy.
Right.
In a perfect logical world, it should sit right next to buy.
Like, you got what?
Yes, you
Right.
bought what? That is the logical structure. But English, and almost every other language, forces us to rip that word out of its spot and throw it all the way to the front of the sentence. What did you buy?
And we have to add the word did, which is just filler. We're adding extra words and moving things around. That does not sound economical to me. That sounds like bad packing.
It seems to violate the economy condition, doesn't it? Why do extra work? The text calls this an irreducible fact about human language.
An irreducible fact.
We pronounce words in places different from where they are interpreted.
So is the machine broken? Is this a bug?
The text suggests it's driven by morphology, the need to check off features like tense or case. But then it offers this thought experiment that completely flipped my perspective on it.
I think I know what you're talking about.
It's about telepathy.
Yes. The telepathy argument. I had to read this twice to make sure I wasn't hallucinating.
It's a striking image for a dense linguistics paper. The text asks, what if we didn't have bodies? What if we could communicate purely by mind-to-mind connection?
If we were just floating brains.
Right. If we could transmit our thoughts, our lambda, directly, We wouldn't need to linearize them. We wouldn't need to put one word after another in a straight line.
You could just send the whole concept at once.
We could transmit the whole image of the thought at once.
So if we were telepathic, we wouldn't need sound. We wouldn't need pi.
Exactly. And if we didn't need sound, we wouldn't need to move words around to satisfy the rules of sound. The suggestion here is that displacement, this apparent imperfection, isn't a flaw in the language software.
It's a hardware problem.
It's a compromise with the hardware.
The hardware being our mouths.
Our mouths, our lungs, our ears. We have to force a multidimensional web of thought through a linear tube of sound. That requires compromise. That requires moving things to the edge of the sentence so they can be heard first or last.
That is actually kind of beautiful.
Well,
the messiness of language isn't because we're stupid. It's because we're trying to run high-end software on biological hardware that hasn't been upgraded in 50,000 years.
it's the bare output conditions. The system is perfect, but the interface is the bottleneck.
So this leads us to the biggest fight in the chapter. And I call it a fight because the text takes a very hard stance.
It does.
It's the battle between the picture and the movie.
That's a good way to put it. The debate between representational and derivational theories.
This was the densest part of the reading for me.
Yeah.
Representational is the picture, right?
Yeah.
The final product.
Yes. A representational view looks at the final sentence, the finished product, and asks, is this valid? It checks the rules against the static image. It doesn't care how you built it, only that the result looks right.
Okay. And the derivational view, the movie says the process matters more.
The derivational view says the process is everything. You can't just look at the result. You have to ask, did we follow the right steps to get here?
But why? If the sentence comes out sounding right, who cares how the sausage was made?
Because sometimes the final picture lies to you.
Lies.
It hides the evidence. The text uses a specific example from Hebrew phonology to prove this, and it's a bit of a detective story.
Okay, walk us through the detective story.
So take the Hebrew word ganvu, which means they stole.
Got it. Okay.
The root of this word consists of 3 letters, G, N, and B.
G, N, B.
Got it.
Now, in Hebrew, there is a specific rule called spirantization. Basically, if a hard B sound follows a vowel, it softens into a V.
Okay, simple rule. If there's a vowel, B becomes V.
So, looking at the word ganvu, you see the V,
Yeah.
but look at what comes before it. G-A-N-V-U. Is there a vowel before the V?
Ganvu. No, there's an N. That's a consonant. Exactly. So if you take the representational view, if you just look at the static picture, you say, wait a minute. This breaks the rules. Why is this a V? It's touching an N. It should be a hard B.
Right. The picture makes no sense.
It looks like a mistake.
But if you watch the movie, the derivation, it becomes clear. In the history of building that word, there was a vowel there.
There was, yes. In the underlying steps, a vowel was inserted. That vowel caused the B to turn into a V, and then a later rule deleted the vowel.
It's a hit and run. The vowel showed up, changed the letter, and then fled the scene.
Perfectly put. The context that explained the change was wiped out. If you only look at the output, it's inexplicable. If you look at the derivation, it's just simple cause and effect.
That really clarifies it. The picture view forces you to invent all these weird exceptions. Oh, the rule works unless it's Tuesday or unless it's this specific word.
Right.
But the movie view says, no, the rule always works. You just missed the scene where it happened.
That is the minimalist argument. Complexity in the output is often just the result of very simple steps applied in a sequence. The text uses an English example too. Decide versus decision.
Oh, right. I never questioned this, but they sound totally different. Decide has a long I. Decision has a short I. And the D turns into a ZH sound. Decision.
If you just look at the spelling or the final sound, it's messy. Why? The change. But if you look at the derivation, you see a sequence. Step 1, add the suffix. Step 2, the stress moves. Step 3, because the stress moved, the vowel shortens. Step 4, because the vowel shortened, the consonant softens.
It's a domino effect.
Exactly. Each step is a simple physical reaction to the one before it, but the final result looks nothing like the starting point.
And this applies to the sentence structure too, right? Not just sounds.
Yes. The text argues that syntax works the same way. A noun moves to a verb. The verb moves to an inflection. Each move is tiny. The text calls it local.
Like moving a chess piece 1 square at a time.
Yes. But if you do that 5 times, the piece ends up on the other side of the board, and if you only see the start and the finish, it looks like magic. How did the noun get all the way over there? The static picture misses the logic. The process is the logic.
So to truly understand language, we have to stop looking at sentences as objects and start looking at them as histories.
Correct. The computational system is derivational. It's a process.
There is one last constraint the text mentions, and I want to touch on it because it sounds almost restrictive. The condition of inclusiveness.
This is the final lockdown on the system.
It says the final output can consist of nothing except the properties of the items from the lexicon.
Meaning, no new stuff.
What counts as new stuff?
Think about cooking. You go to the market and buy your ingredients. Lexical items, potatoes, carrots, beef. You can chop them, boil them, mash them, combine them. But you cannot serve the dish and suddenly have a solitary whole artichoke sitting on top that you never bought.
So the language machine can't just invent a symbol or a tag to help it solve a problem.
Exactly. In older theories, linguists used to use indices or draw lines between words to explain how they connected. This text says, no, you can't add lines, you can't add numbers. You can only use the features that came with the words.
It's a closed loop.
It's a perfect closed system. No deus ex machina. You have to solve the puzzle using only the pieces in the box.
This really circles back to the beginning. We started with this question, how perfect is language? And I came in thinking, not perfect at all.
And now?
Now I'm thinking it's actually kind of terrifyingly perfect, but in a mechanical way.
It's a biological machine that hates wasted effort. It drives relentlessly towards those two interfaces, sound and meaning, and it's defined by the process of construction.
And the coolest takeaway for me is that the messiness, the displacement, the weird sounds, the exceptions, isn't because the system is dumb. It's because the system is solving a really hard problem.
The problem of linking a silent, nonlinear thought to a noisy, linear mouth.
It's an optimal solution to a physical constraint.
And that leads to the thought I want to leave you with. We talked about the telepathy experiment.
Yeah.
If the only reason we have phonology, the only reason we have grammar rules about word order and sound changes, is because we have bodies.
Uh-oh. I see where you're going.
It makes you wonder how much of what we call universal grammar is actually about language and how much is just about the human interface.
If we were AI, if we were disembodied minds in a server,
Or aliens who communicated by flashing colors, would their grammar look anything like ours? The Minimalist program suggests that the core engine, the syntax, the ability to combine concepts might be universal. But the rest, the stuff we struggle with in French class,
yeah.
that might just be an accident of having lungs and a tongue.
So basically, my mind is a supercomputer and my mouth is a dial-up modem.
That is a very charitable way to put it.
I'll take it. Next time I trip over a sentence, I'm not going to blame my brain. I'm going to blame the hardware.
Sounds like a plan.
Thanks for helping us unpack the architecture of the mind today.
Always a pleasure.
And thank you all for listening. Keep thinking, keep driving, and we'll see you in the next deep dive.